When we have equations of lines, sometimes we want to find the equation of a line that is parallel to that original equation, and sometimes we want to find one that is perpendicular to that original linear function. So here it says find the equation of the line in slope-intercept form that is passing through the point -4, 3, and is parallel to 4x minus y equals 3, and then is perpendicular to 4x minus y equals 3. So what I'm going to do first is I'm going to find the original slope. So find the original slope. So we've got 4x minus y equals 3. I'm going to subtract 4x from both sides and then divide by -1. So the original slope is 4, or 4 over 1. In fact, I can use y equals 4x minus 3. I can plot the y-intercept, and I can go up 4 units, right 1, up 4 units, right 1, down 4 units, left 1. And I can draw that original line. It almost looked like that wasn't going to be a line at all, and it was magic. Okay, so we have a slope of 4. We want to find a line parallel. Well, knowing that parallel means that you will have lines that never intersect, we can use this graph and we can find that parallel line. Okay, so I'm going to do that. How would I find a parallel line? Well, a parallel slope is going to be the same. So parallel lines have the same slope. Parallel lines have same slopes. Perpendicular lines have opposite reciprocal slopes. So since I have to find both a parallel and a perpendicular, I'm going to write that down. My parallel slope, that's a symbol for parallel, is going to equal 4. And my perpendicular slope, that's the symbol for perpendicular, is equal to the opposite sign, so it's going to be negative, and then I take the reciprocal of 4, which is 1/4. And now I'm ready to write the equation of a parallel line that passes through -4, 3. I'm just going to rewrite that point here with a slope of 4, parallel 4. So my parallel slope is 4, and it goes through the point -4, 3. So I'm going to use y minus 3. I'm going to use point slope form is equal to the slope times x minus -4. So that will be x plus 4. Y minus 3 equals 4x plus 16. Y equals 4x plus 19. We add 3 to both sides, and we get our answer in slope-intercept form. Now, it helps if you make sure that that's what they wanted you to do with slope-intercept form at the very end, so that you know that your answer is in the form that they want, that they've asked for it to be in. Perpendicular would have a slope of -1/4, and it's still going through the point -4, 3. Y minus 3 equals -1/4 times x minus -4 would be x plus 4. Y minus 3 equals -1/4 x minus 1. I just distributed knowing that 1/4, -1/4 times 4 was going to clear the fraction. And then I add 3 to both sides, and I get y equals -1/4 x plus 2. Now, y equals 4x plus 19. The way I drew this is going to be really difficult for me to sketch on this plane, because 19 would be way up here but it's going to come down here. So I can't plot this with the y-intercept, but I can plot it by putting in, let's say, a -4. If I put a -4 in, 1, 2, 3, 4, I would get a 3 out. 1, 2, 3. Let me make that red. And if I put a -5 in, I would get a -1 out. So you could see down 4, left 1. And I could go up 4, 1, 2, 3, 4, right 1. So this line, I'm going to draw it anyway, is parallel and it's way off to the left. The green line goes through the y-intercept of 2 and has a slope down 1, right 4, which is off my screen, or up 1, left 4. Up 1, 1, 2, 3, 4. Perpendicular means it makes a right angle. So you can see the red and the blue line are parallel. The green and the blue line are perpendicular. The green and the red line are also perpendicular. And that's an example of parallel and perpendicular lines.